Greetings and welcome to another Dev Bootstrap screencast. In this screencast, I'm going to show you how you can debug your smart contracts using Truffle CLI Debugger. Let's get started using a very simple contract. By the way, the information on the Truffle Debugger and how to debug your contracts is also, of course, on the Truffle Suite website. It gives you full information about how you can start the debugger from your tests, from an existing transaction hash, using the Truffle command line, how to use the debugging interface, and all the commands and everything. And this is essentially what I'm going to go through. So the first thing is just to take a look at the contract we're going to test. So this is it, simple store, pretty straightforward. Not going to go into any detail about this. The main thing to know is that you can set and retrieve a value from a smart contract. So what we're going to do is we're going to head over to the terminal and we're going to start up Ganache. And we let that fire up there. And then over on the other side, we're going to start a Truffle console session here, right? So in our Truffle console, once that's started, we can see it's connected to Ganache there. We can run compile just to be sure that our smart contract is compiled, and we can run migrate reset, which will deploy our contract to the blockchain here. And what I can do actually is head back over to the code here and have a look at this test. As you can see, I've got a very simple test for the smart contract to test that you can get the value and that you can set the value. So let's run those tests by just running test, and it all passes. Now, here's where the debugger comes in. Let's run the debugger from our tests. And one way of doing it is, let's say we want to test this. Let's say we want to test this set value here, right? Maybe there's something wrong, or we just want to dig into the code or the behavior. The way to do it is you just simply wrap the entire command, the entire line there, after the await statement with a debug statement. So I'm going to wrap the entire line there with parentheses and then type debug like that. Just the word debug, and save the file. I'm going to head back to the terminal, and this time I'm going to run test with the debug flag like so. And what that will do is start up the debugger, thankfully. And I'm going to zoom in a little bit here so we can see this. And I'll also just take that there. Right, so we can see that the debugger's running. And so what can we do with this debugger? Well, the first thing is you notice kind of like we're lost, yeah? I don't know where we are. So let's run the command L. And the command L is pretty useful. It basically gives you the surrounding code where you're at currently in the debugger. And you can see the purple underline there says that we are actually in the contract definition. Now, if you need to know what the commands are that are available at any time, you can use the command H. This gives you the list of commands right here. And you can see here a bunch of things that we can do with our smart contract while we're in debug mode. So why don't we set a breakpoint? Now, again, let's go back to our editor, take a look at the smart contract, and let's set a breakpoint on line 11, exactly where the value gets set. Now, breakpoints are useful because you can then skip everything and all the parts of the running contract and go straight to that point where you want to stop and inspect the code. So as you can see, I just added a breakpoint by using the B command, and then I just passed in the number of the breakpoint that I want to set. If at any time you want to see what breakpoints there are in your debugging terminal session, just use the question mark. And you can see here that we have a breakpoint at line 11. So to get to that breakpoint, we just use the C command. The C command, as you can see up in the help section here, is continue until breakpoint. Perfect, that's what we want. So if I type C, it will continue now to exactly where we expect, line 11. Okay, so now what? Well, let me clear the screen. You can do that any time, but it doesn't give you, because you can't scroll back up, so I need to do L again to see where we are. Okay, so now I want to know what is the value of new value. Okay, so to inspect any values, we use colon. So colon and then type in the name of the variable that we want to inspect. New value. And as you can see, the value is dev bootstrap. Okay, why is it dev bootstrap? Well, it's because it's coming from here. We set the new value here to dev bootstrap, and then we pass that in here, and we've called the debug statement, so that's all good. Now, if we want to have a look at the entire stack of values in our contract at this time, we use the v command. And the v command is really useful because it gives us all the default values that we get with a contract, or I should say the default properties that we get. For example, MSG property, right, which is an object that we get passed in with every transaction. And we can see here handy values such as who the sender is, the SIG here, which is the function signature. You see it's 93A09352. I've got a handy plugin, by the way, in my code editor here, and I can pull up the function signature for set value. And as you can see over here, it is indeed the same. So that is basically a useful, an interesting thing to see in terms of the transaction there. We can see the function signature. We can also see the data that's passed in as a hex value, the gas, certain data about the block that we're in right now, the block time stamp, which is also transposed to this variable down here called now, which I believe is being depreciated in Solidity 7. So anyway, this is pretty useful stuff. So let's what we can do is we can continue through the code line by clicking the N option, or the N command, which basically continues through the code. And as you can see, it's just continuing step by step and going back up the stack until it's finished. And it says transaction completed successfully. At any time, you can quit out of the debugger, and then you go back into the Truffle terminal session where the test now completes and passes. So that's how to run the debugger through the terminal, like from a test, as we've shown here, using the debug command. Now, you can also start a debugging session using the terminal directly, using the debug command. So let's try that. Let's clear the screen. Let's create an instance of our contract here. So we say simple store deployed. And then let's say get value. Like so, and we can see the value is hello world because we are interacting with this instance here that's deployed, not the test instance. So that's why it's still set to hello world. Now let's update the value. So set value to, let's set it to dev bootstrap rocks or something like that. And as you can see, when we set the value, we get back our receipt, our transaction receipt. And we can use the transaction hash here that you can also see over here on the Ganache feed to actually kick off a debugging session. It's very similar to the one we just saw. We just use the debug command, pass in the hash, and hit enter. And it fires up the debugger. And now we're in the same type of session. There's nothing different in terms of the commands, in terms of how we might use this. So if we do question mark, I can see that there's no breakpoints. So I might as well set a breakpoint at line 11 as we had done before, and then continue to that point, and then inspect the value at that point, which should be dev bootstrap rocks. And we can continue through the function and keep going until the end and the transaction is completed successfully. And then we're still in the debug, so we just quit like so. And now we're back in our terminal session. And it's pretty useful. It's a very useful tool that we can use to help us to build our smart contracts. I'm going to go through another example now where we have a slightly more involved contract that uses inheritance and uses contracts brought in through Node, so I can show you how we can debug these contracts. Okay, so now I'm in a new project and I'm going to test this project as well. This is basically an ERC 721 token. It's actually a very simple implementation, again, just for learning purposes. And the real purpose here is not about the ERC 721, but it's about testing and about debugging. And so it's really the most basic kind of implementation of an ERC 721 token that you can imagine. You can basically mint a token and you can buy the token. And what I'm going to do is I'm going to basically fire up this, I'm going to deploy this contract to my local blockchain, and I'm going to run or create a transaction using this function here by creating a collectible. So I'm going to do all of this in my local blockchain. So I'm going to start up a Ganache session there, and then I'm going to start a Truffle session in here too. I'm going to clean the network. Okay, and then I'm going to run migrate, reset. Okay, and that should deploy the contract. I'll clear the screen. We can see here that it's deployed. So I'm going to just create a variable CC, and I'm going to say collectibles, collectibles deployed. All right, and so now I can call the create collectible method, or create collectible function, and I need to pass in a token ID, a name, and a price, and the price is in way. So let's call that method now. So cc create collectible, and the token ID is in is a uint 256. The name is string, so dev bootstrap rocks, and the price in way, let's just say 10,000 way. Okay, and that was a problem. I think it's just the method name, it's just a lowercase c. So that has now been sent to the blockchain and mined, and we are sent back a transaction receipt, as you can see here. So what we need to do, as before, we just grab the transaction receipt and call debug and pass that in. And that's going to start up our debugger for that specific transaction, the transaction that I just executed. So as you can see, as before, we start off in our contract, and we can inspect variables. We can see what's happening at any point in our contract. So let's start by seeing where we go next. So actually what happened there was I just pressed enter, and enter, by the way, is always set to n, as in next step. So it's the default is always next step. So if you keep pressing enter, it will just go to the next step. Now what I want to do, as we did before, is I want to set a breakpoint. So I'm going to clear the screen here. I'm going to have a look at what breakpoints we have, which are none. I'm going to check the code, and I'm going to take a look at where I want to break. Now I actually want to break here on line 27, just before the mint function is called. Now the mint function is interesting because in this function here, it's actually a call to the inherited contract. So it's a call to ERC 721 metadata. Actually, to be specific, it's a call to another contract that inherits from that. So if we look inside node modules, if I open up ERC 721 metadata, that's the interface. If I open up the actual contract, you can see it inherits from a bunch of other contracts, actually. And this metadata contract does not contain the mint function. The mint function is actually in this contract here, ERC 721. And it's right here. So what we're going to do is I'm going to put a breakpoint in collectibles on line 27, just before the mint function is called. And what I want to do actually is I want to also step into that function. I want to actually check the running Open Zeppelin contract code while I'm doing the debugging. Okay, so I've added that breakpoint. As you can see, I'm verified that it's there. Let's check where we are now in our sort of code as we're running through this. And you can see here that we are on line 21. So if we press C, we're going to continue to line 27. Great. So we're at the mint function. And now, in order to step into this function, if we look at the help, we can see that we need to run the I command. So again, let's clear the screen. Let's check where we are. We're on line 27. Now let's click I and send that command, and voila, we are now inside the ERC 721 contract. The debugger tells you where you are, which contract you're in, just here. So the cool thing is that we can now run the N command to step in and continue to step through the function. Now again, we can add a breakpoint here. This is really cool, because if I do question mark, we can see that we've got a breakpoint at line 27 in collectibles. But let's add a breakpoint in the mint function. Let's have a look at the mint function. Let's put a breakpoint right at the end here on line 265. So since we're in the function, the context is in that function, I can just type B265, and now we have a breakpoint added at line 265. And again, if we inspect the breakpoints, you can see that there's still the breakpoint on line 27 in collectibles, but there's also the breakpoint in the current smart contract that we're looking at. So now if we see where we are and I press C, we continue to our breakpoint, which is in this contract, in the ERC 721 contract. Now, the great thing about this is that we are able to go into any of the contracts that we inherit from, any functions that we execute. We can just go into them and inspect all the variables and take a look at things. So, for example, since we're in the Open Zeppelin contract, if I click V, I see all the variables that are associated with the ERC 721 contract, which is really great, really awesome, because even though we might not be having to change these contracts because these are contracts that have been written and tested and validated by Open Zeppelin, we can still see how they work and see their functionality, which might actually influence our design decisions or our implementation decisions, or even help us with general debugging and troubleshooting. So anyway, if we continue on through this and we go out, eventually we end up back in our top level contract, in this case collectibles. Now another thing I want to show you at this point is what happens when you run V in this contract. And of course you get all the variables of this contract because we're back inside the main root contract. And again, the interesting thing here is that we see all the variables that are pretty useful for us in this method. So you can see here this variable here, token ID to collection info, which is a mapping. And it's a mapping of uint 256 to a strut, a collectible strut. And it gives you the full view of all your variables in your contract. Just to show you over here, back in the collectibles contract, you can see here at the top, I've defined this strut, collectible info, and in the create collection, I've created an instance of this and then added a reference to it in this mapping, the mapping being defined up the top here. And so we can see that and it's very useful if you have a weird situation in a contract where you can't find a token, you can't look up a value, one of your parameters or properties of your strut is empty or wrong, or you get a revert that you weren't expecting. All of those things very, very useful because we can now see all the fields and their values in the contract using this fantastic debugging tool. So if we hit C, we end up at the end of the run of that transaction, and we can hit H and we can load another transaction. We can continue. We can actually restart the contract the transaction if we wish, and so on and so on. So I hope that's given you a little bit of an overview of how to debug your smart contracts using Truffle Debugger CLI. There's more features that you can look at in your own time, but I think I've given you a pretty good gist of what you can do to get started. So I hope you enjoyed this video. Please hit the like button, please subscribe, And I look forward to seeing you again soon in the next video. Take care, everyone. Goodbye.